The key to success in working limiting and excess reagent problems is keeping your tires and headlights straight. What on earth does that mean? What are limiting reagents? Well, limiting reagents are those things that are consumed entirely in a course of reaction. An excess reagent are those substances that have some left over, so they're consumed only in part. Look at this old car. Suppose you were on an assembly line, you and a friend of yours building cars. And you have 20 tires and your friend has 14 headlights. How many completed cars could get past the two of you, the last two in line in this assembly process? Well, from the 20 tires, you could finish off 5 cars because there are 4 tires to a car. And your friend with 14 headlights could finish off 7 cars. But how many cars could get by? Well, for sure, 7 cars couldn't because there'd be 2 of them without any tires. What is your limiting reagent? Your limiting reagent is the 20 tires, even though in this case that happens to be the larger number, and that's not always the case. But you're going to run out of tires before you run out of headlights. And your excess reagent is the headlights. You're going to be able to use up 10 of those headlights and have 4 of them left over. Now here's a problem, and remember, keep your tires and headlights straight. You want to calculate the weight of nitric oxide produced when 5 grams of manganese reacts with 10 grams of nitric acid. I suggest that you start with your 5 grams of manganese and find out how much nitric oxide, that's NO, could be produced. And then do the same thing with your nitric acid. And let me show you why. So let's perform the calculation with manganese first. It doesn't matter. Could have performed it with either one. 5 grams times 1 mole of manganese over 54.9 grams per mole times 2 to 3 mole ratio. That's 2 in front of the NO over 3 in front of the MN. Remember, it's what you're looking for over what you've got. If you don't know that, go back and look at a unit on mole-to-mole ratios. Times 30 grams per mole. That is the molecular weight of nitric oxide. And that would give us 1.8 grams of nitric oxide produced if and only if manganese is the limiting reagent. Now let's try it with nitric acid. We have 10 grams of nitric acid times 1 mole over 63 grams times a 2 to 8 mole ratio. 2 moles of nitric oxide produced for every 8 moles of nitric acid used times 30 grams per mole gives us 1.2 grams. Okay, folks, compare the results. What is the amount of nitric oxide that could be produced? The answer is 1.2 grams. Well, now, wait a minute. Why couldn't I produce 1.8 grams? The reason is you're going to run out of nitric acid first. So you can only produce 1.2 grams. This is your limiting reagent, this nitric acid. And your 5 grams, that is your excess reagent. Some of that is going to be left over. And don't you tell me that you can have 3 grams of nitric oxide produced by adding those two together. That would be like saying you've got 20 tires and 14 headlights and can produce 10 cars. And you and I both know that's not going to work. Now try this one. Using this equation, let's calculate the weight of nitric oxide produced when 12.3 grams manganese reacts with 100 milliliters of 20% nitric acid having a density of 1.10 grams per mil. We're going to use the same procedure. This time I'm going to start with the manganese, if you don't mind. 12.3 grams times a mole of manganese per 54 grams, that's right, times what's the mole-to-mole ratio? It's 2 over 3, times the mass of NO, which is 30 grams per mole. And when I worked this through, I came out with 4.48 grams of nitric oxide produced. Look at those units. Cancel your units. Now let's go back and look at the nitric acid. I have 100 milliliters of nitric acid with a density of 1.10 grams per mil, but it's only 20% nitric acid. So I multiply the 1.10 grams per mil times the 100 mils. That gives me the weight of nitric acid solution. Take 20% of that, which is the weight of the nitric acid itself, times 1 mole of nitric oxide, 1 mole of nitric acid per 63 grams. Sometimes you have to listen to what I mean and not what I say. Times a 2 to 8 mole ratio, that's nitric oxide to nitric acid, times 30 grams per mole, gives me 2.62 grams. Now, how much nitric oxide could be produced? What is the limiting reagent? Well, the limiting reagent apparently is that nitric acid. How do I know? Because only 2.62 grams of the nitric oxide could be produced. We ran out of nitric acid before we ran out of manganese. Now here's a good question. What percent of the excess reagent is used? In other words, what percent of the manganese was consumed? Well, there are several ways to work that. You could take that 2.62 grams of nitric oxide, plug it in, work it backwards, figure out the weight of manganese, put that weight over 12.3 grams times 100. But that's the hard way. Here's the easy way. To find the percent of excess reagent used, take 2.6 grams. That's the amount that was produced from the limiting reagent. Divide it by 4.48 grams. That's the amount that would have been produced had the excess reagent been all consumed. Times 100 tells us that 58.5% of the excess reagent was actually used. Look at that and see if it makes sense to you. It's certainly a quick and easy way to do it, isn't it? Here's another interesting problem that sometimes gives students trouble. We want you to use this equation, the same one we've been using, but we want you to find the excess reagent if 10 grams manganese metal is allowed to react with 10 grams of nitric acid. Now in this problem you don't have another compound to direct your query to. For example, you aren't taking each one of those reagents and looking for a third one. You're looking for those two with respect to each other. And here's a way to do it. Start with 10 grams. Let's start with 10 grams of manganese. We take our 10 grams of manganese times 1 mole over 54.9 grams. Now we're going to find out how much nitric acid is required to react with that. It's times an 8 to 3 mole ratio times 63 grams per mole tells us that we are going to need 30.6 grams of nitric acid. Now folks, we don't have 30.6 grams of nitric acid. We only have 10 grams of nitric acid. So what is the limiting reagent? The limiting reagent is the nitric acid. We cannot possibly use this reaction to its entirety with manganese because we will run out of nitric acid first. The nitric acid is limiting. How do we know? Just exactly what we said. We don't have a sufficiency of the nitric acid to react with that 10 grams of manganese. Therefore, the manganese is in excess. Brought to you courtesy of the Chemistry Professor, offering complete courses in chemistry on DVD. Visit us at our website at www.chemistryprofessor.com.